video, we will show how the data distribution agent, also known as DDA, is integrated with the Edges platform. The data distribution agent is an open source component that allows to easily build loosely coupled multi-agent applications based on data center interaction patterns. By utilizing these patterns, we can build self-coordinating and collaborating systems with ease. In Edges terminology, DDA is a resource that functions can interact with. By using DDA within Edgeless, we can easily integrate external systems with the platform. Through that, we can extend our functionality by implementing additional business logic that gets executed on demand on the Edgeless platform itself. During this demonstration, we came up with a simple use case scenario where we will show the strength of the data distribution agent. In this scenario, we will have an Edgeless workflow which ensures that the robotic arm is protected from overheating. Let's imagine the scenario in the following way. When we have a temperature sensor and a robotic arm that needs to move when the temperature changes. The robotic arm is performing operations on an assembly line and is sensitive to temperature changes. If the temperature surpasses 60 degrees Celsius, the arm should move up to avoid permanent damage. However, when the temperature drops below 40 degrees Celsius, the arm can safely move back down and resume working as previously. The entire setup can be seen in this diagram. The sensor and the robotic arm are separate industrial components shown on the left and on the right, and they use the DDA Go library to communicate with each other. For the purpose of this demo, these components are simulated using simple mocks. Also for demonstration purposes, we have provided simple web UIs that will make the entire demo more tangible. Starting from the left side of the diagram, the temperature sensor periodically generates temperature readings that are also displayed in the web UI. These readings are published as DDA events, which is a one-way communication pattern that allows for information dissemination. The Edges workflow, consisting of two functions, is running on the Edges platform shown in the middle of this diagram. This workflow is responsible for first receiving these events, which happens in the function 1. These events are received through the DDA resource. And after checking the out-of-bounds condition described previously, the second function gets invoked, which accordingly moves the arm up and down. If the temperatures do not surpass certain values, the robotic arm is just not moved up or down. Finally, on the right, we see how the robot arm simulation communicates with the rest of the system, and it also has a web UI to show how the arm moves. On the bottom, we see an orange line, which demonstrates the overlay network created by DDA. Now, we will move to showing a live demo of the entire setup. First of all, we will run the simple edgeless cluster consisting of a single controller orchestrated in a node. As we can see on the right, we have the two web UIs that demonstrate the temperature readings and the robotic arm. As we can see, the temperature is changing on the bottom, yet the robotic arm is not moving yet. In order to make the robotic arm move based on the logic described previously, so based on the temperature values, we have to start the workflow, which we'll do right now. And after starting this workflow, we can almost immediately see that the robotic arm now reacts to the event. So, for instance, we can see that now the temperature sensor values moved down, moved to the green area. This is under 40 degrees, so the robotic arm can stay down. Now, we've seen that the temperature sensor actually reached values that are higher than 80, hence the robotic arm had to move up. All of this interaction is running simply on the Edgeless framework without having to modify any of the pre-existing real-world components. Summing up, we have demonstrated that by utilizing DDA within the Edgeless platform, we can easily extend the behavior of external components using the data-centric communication patterns available in the agent. Thank you for your attention.